Have you ever stopped to think about the invisible magic that connects us all? 1 minute, you're streaming your favorite show, the next you're video calling a friend across the country, then ordering a pizza right to your door. It all feels so seamless, so instantaneous. But how does it really work? What is the internet, beyond the glowing screens we hold in our hands? It's easy to picture the internet as some kind of ethereal cloud, a digital ether floating around us. But in reality, the internet is far more tangible, a colossal, intricate web of physical wires, machines, and rules, all working together in perfect sync. Imagine it not as a cloud, but as an incredibly vast, global postal service, or perhaps a massive highway system, but one designed purely for information. At its core, the internet is simply a network of networks. It's not one giant computer, but billions of connected devices, your smartphone, your laptop, even your smart refrigerator, all talking to each other. But how do they talk? Let's start with the physical stuff. When you're at home in, say, Chicago, and you want to look something up online, your device connects wirelessly to your Wi-Fi router. That router, a small box in your living room, isn't magic. It's connected by a cable, maybe coaxial, maybe fiber optic, to the outside world, to your internet service provider, or ISP. Think of companies like Comcast, AT&T, or Verizon here in the US. Your ISP is like your local post office. They're your on-ramp to the internet superhighway. From your local ISP, your request travels further. It leaves your neighborhood, perhaps through thick bundles of fiber optic cables buried underground, or strung along utility poles, crisscrossing cities and states. Fiber optic cables are incredible. They're thin strands of glass, thinner than a human hair, that transmit data using pulses of light. Light travels incredibly fast, making these cables the backbone of our modern internet. And it doesn't stop at the land's edge. To connect, say, someone in New York to someone in London, those fiber optic cables plunge into the ocean. Thousands of miles of undersea cables lie at the bottom of the Atlantic and Pacific, forming an invisible, global nervous system. These aren't just one or two cables. There are hundreds of them, each capable of carrying an astonishing amount of data, linking continents together. So, when you're chatting with a friend in Europe, your words are literally traveling across the ocean floor. These cables lead to giant data centers, huge buildings filled with thousands, even millions, of powerful computers called servers. If your home computer is like a single book, a server is like an entire library, storing websites, applications, videos, and all the digital content we access daily. When you visit a website, you're essentially asking a server in one of these data centers to send you a copy of that website's information. Now, how does your request, say, to watch a video, navigate this sprawling network of cables, routers, and servers to the correct destination? This is where data packaging and addressing come into play. Imagine you want to send a giant book across the country. You wouldn't send the entire book in one go. Instead, you'd break it down into individual pages, put each page in a separate, small envelope, label each envelope with the destination address and a page number, and then send them all off. The internet does something very similar with your data. When you send an email, load a web page, or stream a movie, your data is broken down into tiny pieces called packets. Each packet is small, typically around 1,500 bytes, and contains a small chunk of the data, plus information about its origin, its destination, and its order within the original message. This breaking down into packets is crucial for efficiency and reliability. If one packet gets lost, only that tiny piece needs to be resent, not the entire message. To ensure these packets find their way, every device connected to the internet has a unique numerical label called an IP address. Think of it like your home address, but for your computer. For example, an IP address might look something like 192.168.1.1. When you type google.com into your browser, your computer doesn't know that name directly. It needs an IP address. This is where the domain name system, or DNS, steps in. DNS is essentially the internet's phone book. When you type google.com, your computer first asks a DNS server, "What's the IP address for google.com?" The DNS server responds with the correct IP address, perhaps 142.250.191.46. Only then can your computer send its request packets to Google's server. It all happens in milliseconds. So fast you never even notice it. Once your computer knows the IP address, those packets are sent on their journey. They travel from your home router, through your ISP's network, and then through a series of other routers spread across the internet. These routers are like the traffic cops of the internet. They read the destination IP address on each packet and intelligently forward it along the most efficient path towards its target server. If one path is congested, a router can dynamically send packets down an alternative route. Your data packets might not even all take the exact same route, they could arrive at the destination server slightly out of order. But don't worry, they all arrive safely, thanks to a set of rules called protocols. The most fundamental of these is TCP, IP, Transmission Control Protocol, Internet Protocol. TCP ensures that all packets from a message are correctly reassembled in the right order at the destination. It also checks for errors and requests resends if any packets are missing or corrupted. IP, on the other hand, handles the addressing and routing of those packets. When you're browsing the web, you're using another protocol called HTTP, or Hypertext Transfer Protocol. If you see HTTPS, that stands for secure, meaning your connection is encrypted, protecting your data from prying eyes, essential for online banking or shopping. So, the next time you're video conferencing with family in California, or checking game scores from your favorite team, or simply scrolling through social media, remember what's happening behind the scenes. A monumental dance of light and data. Your request broke down into tiny packets, each labeled with an address, hurtling through fiber optic cables, crossing continents under oceans, guided by intelligent routers, looked up by digital phonebooks, and reassembled perfectly by protocols, all to bring you the information you desire. The internet isn't a mystical cloud. It's a testament to human ingenuity and a staggering feat of engineering. A physical, global infrastructure that quietly powers our modern lives, connecting us all in ways that would have seemed like science fiction just a few decades ago. It's a truly amazing world, hidden right beneath our fingertips.